over the years, to keep up with the times, amendments have been added to the base Wi-Fi specifications. Among the most prominent of these amendments are physical layer subsystems that provide Wi-Fi systems with the capability to communicate with higher and higher data rates. So as time has progressed and technology has improved, we have seen the introduction of various amendments such as 802.11b, 802.11g, 802.11n, 802.11ac, and so on, which have added capabilities to Wi-Fi. Now, these are not the only amendments that have been added to the base specifications over time, but they tend to be the most well-known because you can find them on product packaging and labels, since they have direct impacts on what you can do with the system. For example, you get higher and higher data rates as you go up and get to the more recent amendments. There are also other amendments that are more behind the scenes and might not be as well known to people. We will briefly go through what these amendments are and the frequency bands they use and things like that in the next few minutes. In 1999, two amendments were added to the base Wi-Fi specifications, one of them being 802.11b and the other 802.11a. Originally, the base Wi-Fi specifications only allowed for communications up to 2 megabits per second. So 802.11b was known as a high-rate physical layer because it enhanced the capability to go up to 11 megabits per second through the use of something known as CCK, or complementary code keying. 802.11b was designed to work in the 2.4 GHz unlicensed ISM band. Simultaneously with 802.11b, work was being also done on something which was known as 802.11a, which it came out slightly later than 802.11b, also in 1999, but the numbering is this one's A and the other's B because this one was started slightly before 802.11b. 802.11a goes further than 802.11b in some ways because it is using OFDM, so it's the first Wi-Fi physical layer to use this advanced transmission scheme, OFDM. And with OFDM, we are still seeing OFDM being used in more recent systems like LTE. Also, 802.11a was the first to use the 5 GHz bands. There are pros and cons of using 2.4 GHz versus 5 GHz. 5 GHz propagation is not as good, so the signals do not propagate as far. But 802.11a has the benefit then of operating in a less cluttered band, because 2.4 GHz you can find lots of other transmitters there, other systems. With unlicensed systems, that's one of the problems you get. However, at the time that 802.11a emerged, things were not as cluttered in 2.4 GHz, so it was not really successful. People were sticking with 802.11b in the easier to work with 2.4 GHz band. And another point about 802.11a is that it offers adaptive data rates. So if you're not able to actually get the 54 megabits per second maximum data rate, you can still communicate, but the data rates might be scaled back to 48, 36, 24, and so on megabits per second. This depends on the channel conditions. It will try to give you higher data rates if possible. And here are some of the system parameters having to do with the OFDM system. Since we had this issue about using 802.11a, which comes in the 5 GHz band, and it's not really backward compatible with 802.11b, hardware manufacturers did not want to include hardware support, which includes antennas, radio transmitters, and receivers for both 2.4 and 5 gigahertz. The next amendment to be introduced for the physical layer was 802.11g. This takes an OFDM system that works up to 54 megabits per second, and instead of operating at 5 gigahertz, this comes down to 2.4 gigahertz. So it's also backward compatible with 802.11b. It therefore has these advantages over 802.11a, that it can maintain that 54 megabits per second, but work more nicely with 802.11b. This came out in 2001, and it was a great success. Because of these backward compatibility reasons, it's more cost effective to make multi-mode Wi-Fi devices that support both 802.11b and 802.11g. So it was a great success. Even while 802.11g was emerging, work already began on the next generation of Wi-Fi physical layer. And in fact, this was not just the physical layer, there were also enhancements in the MAC layer. This was quite a major step forward because multiple new powerful ideas were introduced in 802.11n. So you had greater throughput up to 300 megabits per second in 20 megahertz, and then there was the introduction of larger channels as well, 40 megahertz channels, so they got you up to 600 megabits per second. Plus various other ideas like data aggregation, MIMO, which is multiple input, multiple output, and that refers to multiple antennas on both the transmitter and receiver sides. And that gives you longer range, increased reliability, all these other